When you think of precision, speed, and reliability in strapping machines, there's one key component that makes it all possible: the sealing head. It is the heart of the strapping system, and it determines how efficiently and securely your product is strapped. Today, we're breaking down the different types of sealing heads we offer at EAM-Mosca, what they do and where they perform best, and how they will help keep your business moving. Hi, welcome to the Mosca Minute. My name is Mallory, and welcome to our brand new segment presented by EAM-Mosca to ensure that you're informed on the latest and greatest in company news, industry news, and anything else that you need to know so you can achieve nonstop performance. Okay, let's get started. When it comes to end-of-line strapping equipment, every strap applied to a product represents the perfect combination of tension, precision, and strength. At the center of that process is one of the most critical components in any strapping system: the sealing head. This is where the strap is fed, tensioned, welded, and cut, all in a matter of milliseconds. The design and performance of the sealing head determines not only the speed of operation, but also the reliability and the consistency of each strap applied to the product. At EAM-Mosca, sealing head technology has evolved over decades of engineering refinement. From heat and friction sealers to our proprietary Sonics ultrasonic sealing heads, each is designed to meet specific production demands. Understanding how much sealer type functions will help you choose the correct system for your line to maintain optimal performance. Joining me today is Chris Steiner, our very own training development manager at EAM-Mosca, who will walk us through the different types of sealing heads, how they work, and what makes them such a critical part of our packaging solutions. Chris has been with EAM for over 25 years, working in various roles, witnessing the evolution of our machines and sealer heads. That being said, let's delve into the nuts and bolts of Mosca's strap heads. Hey Chris, thank you for joining me on today's Mosca Minute.
Thanks, Mallory.
Why don't you tell everyone about yourself?
So my name is Chris Steiner. I am the training development manager here at EAM-Mosca. Been here for about 32 years. I kind of joke that I was born on one of the machines here that's in the lobby, one of our older machines. What I do is I help curate content for training purposes, whether it be for our technicians, our customers, other in-house personnel, sales. What we look to do is to try to create a training environment that we can get as many people through as possible and on as much equipment as possible.
So right off the bat, what is a strap sealer?
So the strap sealer essentially is the heartbeat of the strapping machine, performing all functions of the strap cycle over and over repeatedly. And the sequence of a strap cycle is broken up into about 7 steps. It begins with pullback, we go to tension, we go to cut, weld, cool, release, and then we go back to the home position again to refeed. That entire process takes about 1 second, give or take, depending upon the size of the strap arch and the product that's being strapped. The sealer essentially does exactly what it's called. It takes the 2 ends of the strapping material and it joins them together to make one continuous strap around the product.
So what are some differences between the side seal, bottom seal, and top sealers?
Okay, so each of them does have kind of a unique place in the industry. The side seal primarily is used in when there's tighter gaps in the upstream and downstream conveyor, or whether it be tabletops, whatever the product flow is. If you're tight on floor space from beginning to end, the side seal is definitely attractive for that, because the only part of the machine that is actually in the product line or the flow would be the track arch, which is the thinnest part of the machine. The larger portion, larger body of the machine is on the outside then of the product flow line. So from that standpoint, it takes up the least amount of room in a line. The other advantage of it is that if you're working in a low conveyor height situation, you don't have the rest of the machine or the bulk of the machine underneath. So basically you're able to take the strap track arch down very low to the ground to meet very low conveyor height. One of the other big positives about it as well is from a maintenance standpoint. So because the welding head or the sealer head is not below, any dirt and debris that is built up from the manufacturing process can actually just fall straight down to the ground, and it actually doesn't just rest inside the head, and it probably is less maintenance intensive than at that point. The only thing you have to be concerned about with a side seal application is that you do have to make sure that the product is justified up against the side of the machine where the sealer is at all times. So you can't have product, floating to the left or to the right as it's coming down the conveyor path. So moving on to the bottom seal machine, which is probably our most popular machine. It's more simplistic. There's cost advantages when it comes from the manufacturing standpoint. The way that product is conveyed down, as long as it's in a consistent centered position, this is favorable in those type of applications. You only have to worry about really covering a very small part of the sealer area, and you don't have to worry about keeping it completely to one side or the other. There's no indexing required, so you don't have to worry about making a sealer head move out to meet the load. So again, as long as the product is covering up part of the sealer, you'll have no problem welding the product there. It's more versatile. From the standpoint of transport, bottom seal tends to be more simplistic and cost advantageous because you don't have to worry about the product being conveyed to one side or the other. As long as your product is coming down relatively in the center of the flow, there's no indexing required of the head, and it's in a relatively consistent position. Again, it's the most commonly used. Typically, these machines have a built-in conveyor to help handle the product flow, transport in and out of the machine, and it is more the lower cost option because of just the versatility of it. With the top seal, these are mostly seen where your compression is what we refer to as a platen system, which comes down to compress the product or hold the product for stability while it's being strapped. And it's a simplified design because it combines both together, and you'll typically see it in a much higher tension application, such as like the building products industry.
What is the energy usage for these sealer heads?
So I'd have to say the heat sealer would be the most energy consuming, because when you first turn a heat seal strapping machine on, from the moment you turn it on, it's on. It has a longer heat up time to get up to operating temperature, as opposed to the sonics and the friction. Basically, they're only activated when they need to be. So otherwise, they just sit idle. They're told to go, and during the weld is when they're activated. When it comes to energy usage, Sonics is superior because it is utilizing the latest technology.
Need help choosing the right setup for your operation? Visit EAM-Mosca.com or talk with your application specialist. Thanks for watching, and stay tuned for more end-of-line education with EAM-Mosca.